Hi, welcome to a review of types of numbers. Keeping in mind that number development pretty much followed human development in terms of their thinking and how to be able to count things, we begin with the natural numbers. If you have a herd of sheep, you need to be able to count them. So 1, 2, 3, 4 sheep. Eventually, you need to be able to determine that you have nothing of something. So you have no sheep left. And that's where 0 is added to the natural numbers, and you now talk about a number grouping of the whole numbers. Okay, you take your sheep to market. You need to indicate that you have now sold your sheep or maybe lost your sheep, and so there is the need for negative numbers. If you take the natural numbers, add in 0, making them the whole numbers, and then include the negative numbers, you are now talking about the group of numbers called integers. Okay, another dilemma. You have 5 sheep and you need to divide them between 2 sons. You need the ability to express 5 divided by 2, which is a fraction. As we all know, you can take a fraction and change that to a decimal. We are now talking about the ratios or the rational numbers. So notice that the rational numbers include the natural numbers, the whole numbers, the integers, as well as all of the numbers in between those, and that gives you the group of numbers called the rational numbers. With the development of the Pythagorean theorem, or with the fact that the circumference of a circle seemed to be based on a particular number named pi, then the development of the irrational numbers came about. The irrational numbers are a special group of numbers, and that's why they're off to the side in this picture, because they represent the group of numbers that are non-terminating, in other words, they never end, or non-repeating. They don't have a pattern to them, so it's not like 0.333333. They don't have a pattern, and that group is the irrational numbers. You notice then that the irrational numbers are in a separate group by themselves. They are not part of the natural, whole, integer, rational number grouping. Of interest to note, recently I saw an article that someone has actually calculated pi to the billionth decimal place, and it still doesn't repeat, and it still doesn't terminate. So, if you're given a list of numbers, how can you classify them? Well, first of all, we know that the natural numbers are the counting numbers. So, of that group there that is listed, 25 is a counting number. It's not a fraction, it's not a decimal, it's a counting number. If we now wanted to talk about the whole numbers, we could add the number 0. But because the whole numbers also incorporate the natural numbers, 25 is not only a natural number, but it's a whole number. Add in the negative numbers, so negative 8 is considered an integer, but because the integers incorporate the natural numbers and the whole numbers, so is 0, and so is 25. The rational numbers, the fractions that terminate. So 0.34 is the same as 0.75. 0.45 terminates, so that's considered a rational number. But wait a minute. Don't forget that the rational numbers also include the natural numbers, the whole numbers, and the integers. So everything that you've previously marked off are also rational numbers. If a number is irrational, it's not any of the above groups. So radical 7 is considered irrational, as is pi, because it does not terminate and it does not end. Finally, think about that Venn diagram for a minute. All of the numbers that were indicated in that grouping were all reals, and so you need to include all of these groups as real numbers. Hope that has helped you to understand the system of numbering that we use and the types of groups that they belong to. Thanks for listening.